Okay, I had to write a little something to the board, otherwise the camera probably would have gone out of focus. Am I still visible? Okay, I think it's good. Okay. Now I'm saying, remember we've got now the expression, one of the expressions we're looking at is s plus 1 over s plus 1 quantity squared plus 3. I'm saying that that's just the same as s over s squared plus 3, except s has been replaced by s plus 1. So, the cosine, okay, f of t equals the cosine of omega t has Laplace transform that we'll call capital F of t. That's s over s squared plus 3, and it's not t, it's s. Okay? So, the capital F of s stands for Laplace transform. I haven't used that notation a whole lot, but it's there in your text, and hopefully presumably you're used to it. But in case you aren't, this is just what it means, okay? The Laplace transform of little f of t is big F of s. If little f stands for the function you're transforming, big F stands for the transform. Okay? F of t then has this Laplace transform. F of s plus 1, that equals s plus 1 over s plus 1 squared plus 3. And that's what we're looking at. So this is the Laplace transform, but with s replaced by s plus 1. So Laplace transform of the cosine of omega t, but with this replacement of s. Okay? Now, the rule says this is f of s minus alpha, with alpha equals -1. Then by the rule I just wrote down, and by the similar rule in your table, your f of s minus alpha is the Laplace transform of e to the alpha t yep. Okay, so Laplace transform of e to the alpha t times your f of t function, which in this case with alpha is equal to -1 is Laplace transform of e to the negative t times the cosine of pi t. So the inverse transform of this is this. Now that supports, actually proves, if you accept that rule for shifting the transform, proves that what I wrote down here was right. Okay? We got e to the negative t cosine of, it's not pi t. Okay, let me come back up here and correct my boo-boo. I'm used to having the pi squared, and I didn't notice that I had a 3. This is the cosine of square root of 3t. Okay. Because when I wrote this, I wrote the 3 here. This should have been omega squared. Because that's the general Laplace transform of cosine of omega t. So I could write s over s squared plus 3 equals s over s squared plus omega squared with omega equal square root of 3, so that the inverse transform of this being the cosine of omega t, the inverse transform of this is the cosine of the square root of 3t. And we've seen that, so I apologize for the error, but this is what we get. And everything I say about the f of s minus a, the shifting, it simply introduces an e to the negative t into this one, an e to the alpha t with alpha equal to negative 1. So that the inverse transform of this expression, where s has been replaced by s plus 1, is just e to the negative t times the cosine of the square root of 3t. Okay, and now that matches this. Okay? Now over here it's just a little more complicated, but very similar. This would be like 1 over s squared plus 3, but s has been replaced by s plus 1. That's going to introduce an e to the negative alpha, e to the alpha t, where alpha is negative 1. Okay? You're going to get the square root of 3, because that's your omega squared there. And you've got a 1 here instead of an omega, just like over here when we did the sign. So you're going to have a 1 over pi factor in this thing. Now, I'm not going to go through that in all of its detail. We're combining the trick that we used here, the shifting trick, with what we did here to get the reciprocal pi. We needed it because we're supposed to have omega up here, and we just had a 1. So 1 over this is 1 over omega times omega over this, and omega over this is the sine of omega t, is the Laplace transform of the sine of omega t. And now we have our entire solution, except that we don't know A, B, C, or D. And to get A, B, C, and D, we have to do the partial fraction. Once we do, we'll be able to put in our A, B, C, and D, write out our entire solution, and test whether it is, in fact, the solution of this equation. Now, I think I've got a short time. Yeah, I've got plenty of time here. The solution to this equation, incidentally, and there was more to the equation. Actually, I didn't write it all down. We had an initial condition, y of 0 equals 3, and y prime of 0 equals, I think it was 5, if it wasn't negative 5. Let me look back, it's negative 5. Yeah, it looks more like an S than a 5, but it's a 5. Okay, this is our equation. Our general solution of this equation, if we do characteristic equation, we're going to get r squared plus 2r plus 4. The solution of that equation is going to be r equals negative 1 plus or minus the square root of 3 times I. Your discriminant is clearly negative. B squared is 4 minus AC is 1 times 4, which is 4, but 4AC is then going to be 16. So you're going to have 4 minus 16, which is negative 12. That's going to give you an I. and the square root of 12 is 2 square root of 3, so when you divide by the 2a, the 2's go away and all that stuff. That's straightforward. Everybody is okay with this. We wouldn't be here, well, I wouldn't say that. Some people might still be here if they didn't know this, but everybody seems to know this. So this implies solutions. Characteristic solution, E, well, let's say A. I don't want to use A. Now I'm going to write down the solution set. I don't want to write down the solution because I'm going to get hung up in symbols here. It's going to be e to the negative t cosine square root of 3t e to the negative t sine square root of 3t might be hard to read, but there it is, and you can write it out as easily as I can. And some combination of cosine pi t and sine pi t. Okay? Just use undetermined coefficients and figure out what the multiple of cosine pi t and sine pi t is, such that when you run it through this equation, you get this. And we see that our solution has all that. There's our cosine pi t and our sine pi t. There's some constants, and we are going to get values of those constants by doing the partial fractions. And those values of the constants should match what you, well, should satisfy the initial condition, okay? And I kind of jumped the gun on that. You get this solution with these constants, and you get a constant times the e to the negative t cosine square root of 3t, and you get another constant, which is d minus 1 over pi, times e to the negative t sine square root of 3t. When we get a, b, c, and d and put them in here, 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 and here, and simplify things, we're going to get a combination of cosine pi t, sine pi t, e to the negative t cosine square root of 3t, e to the negative t sine square root of 3t. That number 1 satisfies the equation, and number 2 satisfies the initial conditions. So we're going to proceed to find our A, B, C, and D and see whether that's really so.